Good day everyone. Today, my group and I will presenting on medicine imaging and therapy with advanced X-ray. This topic explores how far X-ray technology has advanced from its original discovery and how it's now a key part of both diagnosis and treatment in modern medicine. Before we begin, let's meet the team behind this project. X-rays have been around for more than 100 years, but they have evolved in ways we could never have imagined. Today, they are not just used for checking broken bones. Advanced X-ray technologies like CT scans and digital radiography now allow doctors to see inside the body with amazing clarity. These innovations help catch disease early and treat them more accurately. Thanks to continued advancements, X-ray imaging is now a powerful, life-saving tool in modern healthcare.
Medical imaging and therapy using advanced X-ray are a powerful real-world application of quantum mechanics and electromagnetism. They allow us to perform non-invasive diagnostics such as CT scans and fluoroscopy by using X-ray photons to interact with body tissues and produce highly detailed internal images. On the treatment side, radiation therapy uses precisely controlled doses of X-rays to target and destroy cancer cells, minimizing damage to healthy tissues. This field doesn't just improve medical outcomes, it also drives innovation in detector technology, image processing techniques, and also radiation safety standards. Overall, it is a great example of how theoretical physics translate into practical life-saving application in healthcare.
And this is our methodology. First, we create research question formulation. Basically, we ask ourselves the main questions such as what is advanced X-ray, why is it important, and how is it related to modern physics. The second step is we do search strategy development. We search for information using keywords like advanced X-ray, X-ray in medicine, and modern physics. We also make sure to use trusted websites like Science Direct, Cleveland Clinic, and any other hospital websites. The third step is data extraction. We wrote down important points about how X-rays are used for diagnosis and therapy. And the fourth step is organization. We group the information into two parts, diagnosis and therapy. And the last step of our methodology is interpreting the findings. We try to understand how this technology helps doctors and patients in real life, and we also explain the skills needed to be able to operate this technology.
Hi, my name is Adam Farish bin Jalil, and I would like to discuss about challenges encountered while researching about our topic. Our first challenge is lack of research material like website or article. It was really hard to find an article that relevant towards our topic, which means we don't have enough and proper data to collect. Besides, we are having difficulties in understanding advanced X-ray imaging and therapy as it requires a strong foundation in physics. The topic really need a proper understanding to modern physics as they use some term that we are unfamiliar with. Lastly, lack of proper data management, which can lead to errors and failure, was also one of the challenges towards this topic. This is crucial because might be the biggest flaw towards our research. In order to face this kind of problem, now I would like to propose solution to solve the problem. Experts refers to skilled and expert like lecturer, so that we could hear some advice that could help us to manage the problem we had. Second, break down the research into specific sub-areas of interest and consult specialized textbooks or any article connect to the topic. This could help us to understand the topic more deeper. Lastly, implement robust data management plans that include data cleaning, validation, and procedure. The purpose of this implementation was to determine the error and disqualify the corrected data, so our result can be more accurate and precise. Now, I would like to share about concept or theory of radiotherapy dose calculation. Before we begin, what is radiotherapy? Radiotherapy is a cancer treatment that uses high-energy radiation to kill cancer cells. A critical aspect of radiotherapy is dose calculation, which involves precisely determining the amount of radiation delivered to the tumor volume while minimizing the dose to surrounding healthy tissues. Now, after we hear about the concept and theory just now, but what is the importance of this concept? An accurate dose calculation is paramount for delivering a sufficient dose to the tumor to eradicate cancer cells. It is very important for achieving effective cancer treatment while prioritizing patient safety and minimizing treatment-related complications. That's all from me. Thank you.
I will be explaining the factual details of advanced X-ray. In the term of diagnosis, it is the modern version of X-ray. It captures more clearer and detailed images of the inside of human body. It uses digital and latest technology for better quality, like enhancing the clarity and precision. Advanced X-ray also provides high resolution and 3D images, which can give the doctor a better view of their patient's condition. While in the term of therapy, it provides the precise location of tumor volumes and its surrounding structures for treatment accuracy. Other than that, it also uses beams of intense energy to kill cancer cells. As for the relationship of advanced X-ray and modern physics, even though we have explained it in the beginning, here are some other facts we like to add. Advanced X-ray helps in understanding atomic structure and identifying particles like protons and neutrons. It also contributed to advancements in quantum theory and the theory of relativity. Not to forget that it led to technological innovations like radio, long-distance telephone, and improved communication. Here are the examples of the advanced X-ray technology. In diagnosis, we have CT scan and fluoroscopy, while in therapy, we have radiotherapy.
Let's explore how diagnostic and therapeutic imaging techniques are applicable in our daily life. In diagnosis, digital X-ray play a crucial role. They help detect fracture, infection, and dental issue with speed and accuracy. CT scans go a step further, providing detailed internal image that assist in diagnosing tumor, stroke, and internal injuries. Mammography is another vital tool. It used specifically for the early detection of breast cancer, which can be life-saving. When it comes to the therapy, radiation therapy uses high-energy X-ray to target and destroy cancer cells. And with advancements like image-guided radiation therapy, we can now combine imaging with treatment to deliver radiation more precisely, improving outcome and minimizing damage to the healthy tissue.
Now, I would like to share about recent study which can be divided as advancements or controversies in medical imaging and therapy with advanced X-ray. First, we will go through to advancements first. First advancements is the image was enhanced by processing with AI. Artificial intelligence and machine learning algorithms are being integrated to enhance image resolution, automate anomaly detection, and provide real-time processing, leading to faster and more accurate diagnostic evaluations. For example, AI can assist in identifying patterns indicative of diseases like COVID-19 or cancer. Second, digital radiography. They replacing traditional film with digital sensors. Digital radiography offers faster imaging, reduced radiation exposure, and enhanced image quality through manipulation and analysis. This leads to quicker diagnosis and more efficient workflows. Advancements always comes with controversies. Now let's look at the controversies in our topic. The first controversy in this topic is false positive results. Screening with X-ray imaging can lead to false positives, causing unnecessary anxiety, further testing, and potentially invasive procedures without any benefit for the patient. The second is the cost. The financial implications of widespread X-ray screening programs, including the cost of the imaging itself and the follow-up for false positives and its incidental findings, are a subject of debate.
I will be sharing about potential careers related to medical imaging. An MRI technologies used to take picture of soft part inside of the body like the brain or muscles. CT technologies take a special X-ray called CT scan. This help find problems like injuries or cancer. An ultrasound technician, also called a sonographer, use sound wave to make a picture of organ. This is often used during pregnancy or to check the heart. A nuclear medicine technologies give a small amount of self-radioactive materials and take pictures to see how organs are working. A radiation therapist gives a radiation to treat cancer. They make sure it goes exactly where it's needed. They doesn't give too much radiation to the people. A medical physics checks that all the machines are safe and working properly. They help plan the treatment. All these papers work together to help patients feel better and stay healthy.
In case anyone is interested in the potential careers we have mentioned in the previous slide, here are some specific skills you needed. First, communication skills. Radiologic technologists must talk clearly with patients and work well with doctors and nurses. Good communication helps patients feel safe and helps the team to understand each other. Second, computer skills. They need to use special computer systems to look at scan results, update patient records, and write notes. Third, safety knowledge. Knowing safety rules is important to protect themselves and others from radiation. They must also follow hygiene steps to keep everything clean. Fourth, medical knowledge. Basic knowledge of the human body helps them take good images. It also helps them move the patient correctly and keep them comfortable. And lastly, technological skills. They must know how to use and fix imaging machines. This includes setting the right amount of radiation and checking if the machine is working properly.
As professionals in medical imaging and therapy, it's really important that we keep learning and improving ourselves. First, staying up to date with the latest technologies and safety protocols help us do our job more effectively and keep our patients safe. We also become more confident when working with advanced machines and interpreting results. Good communication and teamwork are also essential, and by developing these skills, we can work better with doctors, nurses, and patients. Since this field is always evolving, being adaptable helps us face new challenges without feeling overwhelmed. Continuous learning also supports our career growth, whether that means getting certified, taking on new responsibilities, or moving into leadership roles. And most importantly, by constantly developing ourselves, we give our patients the best care possible using the most accurate and up-to-date methods.
This slide shows some of the main challenges we face in medical imaging and therapy, along with ways to handle them. First, there's the issue of high radiation exposure, which can affect both patient and healthcare workers. To deal with that, we use low-dose imaging techniques and better shielding tools to keep everyone safe. Another problem is that it is hard to get clear images of soft tissues. We can improve that by combining other imaging methods like MRI or using contrast agents. Then there's the cost. These machines are expensive to buy and maintain. That's why we rely on government support, sharing equipment between facilities, and coming up with more affordable solutions. Lastly, accuracy in therapy targeting is super important. To help with that, we use AI-based system and do regular quality check to make sure everything stays precise and on track.
In conclusion, advanced X-ray technologies have revolutionized the way we diagnose and treat illnesses, from highly detailed diagnostic images to precise radiation therapy. These innovations are making healthcare safer and more effective. As future medical professionals and technologists, understanding the science behind these tools is not only essential, it's empowering. With the right knowledge and continuous development, we can contribute to even greater advancement in medical imaging and therapy. That's all for us. Thank you.